And we are live.
All right, hi everyone. My name is John Marabli. I'm a senior here in electrical engineering. Pretty interested. I have a lot of interest in kind of data science, and I've kind of learned over the past few years how to work with R and just analytics in general. So today I'm going to be talking about data mining in R, and it's a pretty complex language to learn quickly, and we only have a short amount of time. So to make it kind of the most valuable for you guys, I'm going to do an overview. I'm actually going to step through Jared Knowles' boot camp. The reason I'm going to do that is because it's the first one, and you can kind of continue along, and it builds off of it. So he put something really good together. We'll step through a little bit of that, and then I'm going to do an example, a real-world kind of example on sentiment analysis and how you can do that in R. So does that sound good? Yeah. All right, cool. So today's goal is to convince you that data analytics in R is interesting, valuable, and even a little sexy. The chief economist at Google says that the statistician is going to be the sexiest job by 2015, and it's 2015. So, and we're going to talk a little bit about how to get started. So just to provide context, in 2000, we just passed over having an exabyte of data, and it's just basically a 1 with a ton of zeros after it. Now we produce 2.5 of that every day. And the amount of data that's produced, much of it is noise if we can't find a way to interpret it. So the computing power, as well as the ability to digitize information, that's kind of creating this sweeping trend across almost every industry to be able to manage large data sets and extract useful information from it. So it's a very specialized skill. It's a relatively new area, and it's highly in demand. There's all these studies that say that there's a huge shortage across every business for these types of skills. So today, again, I'm going to be talking about R. This is actually RStudio. If you download the R, that's actually a simpler version when you're first learning it. But that's the icon for kind of what everyone uses is RStudio. It's just a little kind of more, almost looks prettier. And then I'm going to do an example of sentiment analysis, which is essentially trying to extract kind of consumer information from text. So if you kind of think about that, there's a lot of complicated issues with trying to understand the emotion or the response to something based off text. And R is actually really equipped to deal with that. And I'll show you kind of a high-level example of how to do that. So first, R. So it's built off of S. You'll figure, which is a statistical language. It's pretty old. It's about 10 years old, and it's becoming increasingly more popular. So it was just ranked number 9 by IEEE top programming languages. And the reason it's ranked so highly is, number one, it's open source, and the community is really strong. So the packages that are developed are these kind of plug-and-play packages where it's very robust statistics or robust analysis, and it's really easy for the user to understand it once they're familiar in R. Another strength of it is it's really good at working with large data sets. So you'll find pretty quickly if you're in Excel, things get really tricky when you're trying to, either look at combinations of variables or kind of do, Excel kind of stops at pivot tables essentially, and R kind of has that next layer of functionality, and it's really strong with dealing with large data sets. And it also has built-in data visualization, which is kind of like the who cares anyway. So being able to run analysis, but also, produce an output, whether it's a graph, whether it's kind of a score or a report, it has all that kind of built in and packages on top of it that you can download, install, and then, increase the functionality. So now I kind of want to go through that bootcamp. So if everyone can navigate to this link, jaredknowles.com/R bootcamp. And the reason I use this is because he is doing a better job than any slides I could put together. And I'm going to step through them. And if you want to kind of split screen and play around with kind of the commands he's using, you can do that as well. But you don't have to. If you want to just kind of sit and absorb, that's fine too. The other reason I'm using this one, we're going to go through getting data in, because that's kind of the first step, is because he has a number of kind of presentations or slides that build off of this one. So if you want to kind of continue on it, it'll be very easy to jump right in and be familiar with how he does things. And this is published by Wisconsin, and it's free for public use. So this is where I skipped a few slides ahead. So I mentioned packages, and this is kind of relevant for a lot of reasons. So packages are essentially these little modules that someone else builds and makes it publicly available. Again, that community is really strong. So there could be packages around visualization. So if you want to make some really pretty graphs, there could be a package that you can download for that. If you want to do really intense machine learning, but don't necessarily know a lot about it, there's these packages you can download where you just set the parameters and kind of let it run. And you can rely on kind of the work that statisticians have done, but still add that to whatever application you're doing. So the packages are really kind of where a lot of the strength in R lies. There's over 3,000 available. And it's actually really easy. The way you do it is you just literally type the command install .packages, put the package name in quotes, and it will bounce off of a CRAN mirror, download to your copy of R, and then you just have to load it when you want to use it. So the packages are where you download R was the CRAN, which is the Comprehensive R Network. And that's kind of where they're all hosted, so that makes it easy to go through. So some packages that are great, Plier is essentially, if you guys have used pivot tables in Excel, or if you can imagine kind of looping through data and pulling different variables to aggregate analysis, that's what Plier is. So if you're doing any kind of counts or trying to report on where you're dealing with multiple variables, not just trying to plot X and Y, Plier is a good package to get to know. ggplot2 is like the iconic visualization thing. So that's like all your plotting. It looks great. They make it really kind of user-friendly so you can customize. That's just a few. So basics for R. So data management, to understand kind of everything you have in your workspace, it's just the ls command. And that kind of gives you all your variables, all your tables, things like that. It's object-based. So the people who are familiar with kind of programming, that's kind of the language that you're dealing with. And a lot of things it's best to imagine it kind of as like a data frame. So for instance, like my data would be the data frame. Imagine like an Excel spreadsheet. And then to get, say, the column of the variable that I want, you just use a $ and then the name of that variable if it's titled. So if I want column 6 and it's called column 6, I'll do data frame $ column 6. So that's kind of how you pick out things from a column basis. And you can also, add columns. You can make equations and formulas and then add those in for the entire data set. So that's kind of where you can kind of see the power of R. It's really on the data frame level. The working directory, this is basic stuff. So you want to set or get the working directory. So if you have your files in one area, I mean, if you're programmers, you get that. So set to change it, get to output it. I'm just skipping through a lot of stuff just for time. Okay, so project paths, another kind of similar thing. So you'll just kind of want to organize things. I'm breezing through this because I hope everyone kind of has some programming experience. Yes, no. Using a full path. Okay, so this is missing data symbols. So this is actually an important thing because the way R handles missing data, you'll have missing data. So often when you download a data set or you have a data set, you're going to have missing values in it. And that's important to know when you're running through things. So just to kind of note, there's a difference between NA and null. So NA is a placeholder, so we'll actually say NA when you output something. Null can't hold a place. It's just like a completely missing value. And that'll come into play later. All right. Sorry, I have to get through all this. So as far as getting data in, so because it's open source, you can pull data from almost any source. So you can pull it from a database, a SQL database, or a number of different types of databases. You can pull it from a text file. You can pull it from really every kind of major file storage file. There's some command to get it. A lot of people use CSVs just because it's kind of the simplest thing, and you can kind of mess with it in Excel and pull it in. So this is the basic command. So the way it's set up, they don't use equal signs. They actually use this like arrow, so it's actually like the less than sign and then a dash. So this is the assignment. So read.csv, this is the file name in your working directory, and then it's putting it in this df command, so data frame. So if you guys, actually on the home website, there's like a bunch of sample files. If you want, you can kind of play with that and pull it in. So that will essentially create a table and have it in the data frame. And that's when you can kind of start messing with it. So this is what it'll automatically kind of, the good thing about R is it knows you're doing analysis. So it'll automatically kind of give you some statistics on, what data frame you pulled in. So you can kind of see, the size of it, the different levels, just the number of observations, things like that. So there's a few things. The hard thing about visualizing information is kind of keeping an eye on the data set. So if you run through and you change a bunch of things, it's hard to like visualize that because it's not, constantly output on your screen. So the summary command is helpful if you're dealing with like very numerical data, but you can also use the head command, which is just head, and then in parentheses you put the data frame. It'll kind of print out the top chunk of your information to see it. So that can be helpful when you're working with it. Names, another basic command, gives you kind of all the variables that are in your data set. And again, this is just a note with the versatility of R. So you can pull from Oracle. That's why a lot of industry uses it. So they have all their data warehousing in Oracle, and they can, they have an analyst that kind of pull from it into R, where they can, it's much more malleable to kind of work with. And same with SQL. So this is just adding missing information because a lot of real data sets do have that. And, part of this is the actual coding, but part of it is actually really understanding the problem area and the domain area. So a missing data set, a missing data point in like weather information, it might be a sensor, like, if you can imagine, like a sensor doesn't record for certain values. So like you have to have a way to handle that. And R like really kind of, it makes it robust with handling missing information because that really affects your analysis when you get up to the higher level. So you can check for missing data. So you basically kind of look for that NA placement. So if a sensor didn't record it or you just don't have an observation for that, it'll pull it out, and you can use this command na.omit and then put it into a clean, this is now a clean data frame. Pretty basic stuff. So again, the length command is just to get a sense of, how many observations you have. Unique command, obviously, how many unique observations you have. Okay, so that's just kind of getting data in. So I'm not sure what applications you're going to be doing this weekend, but that's kind of the basics for handling that. Just getting it in and working with it on a basic level. When you have it in, if you're doing kind of basic analysis in it, you'll use the table command a lot because that'll essentially put two variables kind of juxtaposed, so comparing X and Y. So if you want to compare like something over time, you'll do this table command, the data frame that it's in, and I guess like the independent variable, comma, the data frame that it's in, and then the dependent variable. So it's like really easy to just like kind of play around and say like, how is this changing over this certain variable? This is one thing that wasn't in the slides, but the C command is concatenate. So anytime you're adding on either an observation, so a row or a column, that's what you're going to use. So it's really simple. So it's C, and then it's all the arguments that you want to concatenate. So you can concatenate a vector on a column onto an existing data frame, or you can concatenate a vector and put a value kind of on that vector. So picture like another observation. So that's kind of like the bread and butter. People use that a lot, kind of on the basic level of using R. Head is, again, that like summary. It gives you kind of what the table looks like so you can visualize it if you're changing the information. And then to get it out, use the command write.table, write.csv, and what you want to output as well as kind of what you're going to call the file. So again, it's really difficult to kind of dive deep in the time that we have. So I just wanted to give you like the most practical things for me that, I wanted to learn how to load data in and output it and just do basic kind of messing with the data to see basic statistics. But the walkthrough that I linked to, that has kind of more what you're looking for in terms of like specifics or like problem sets. So another great thing is this thing called Swirl. So it's actually a package, and you download it, and it actually walks you through learning R. And I literally can't say enough good things about it. There's 10 lessons in the R programming course, and it'll literally be in the command line in R, and it'll say like, all right, now let's create a table, and it'll tell you what to do, and you do the command. And it's like, now let's add, you know, a column or something like that. So it teaches you, I mean, you can learn, you'll go from here to here just going through the Swirl package. So it's really easy to download. You just do install.packages, Swirl, and you'll select the R programming course, and there's 10 lessons in there. And it's great because you're actually typing out command by command. If you spend an hour doing that, you'll really increase in kind of what you know. And again, that boot camp is pretty well regarded kind of in the R community. All right, so now I'm going to get to an example, just because the high level. So this is something by Jeffrey Breen. I've used it a couple times because I think it kind of captures the challenges of data analytics, but also the power of it. So this is going to be sentiment analysis on tweets, public tweets about airlines. So if you can, you know, if you've ever been on a delayed flight or terrible customer service, you know, our generation is the one that's going to kind of complain about it on Twitter. So basically the framework that he made was to pull tweets using the Twitter API, pull them into R, run an algorithm on it that scores a tweet based on the sentiment. So if you can imagine, like, you know, a tweet with a bunch of curse words, that's going to have a negative sentiment, whereas a tweet with, you know, lots of exclamation points and, you know, a smiley face, that's going to have a positive sentiment. So that's the basic idea. And this type of thing would be really difficult to do in something like Excel or even just basic programming languages. You can probably do it in Python pretty easily. There's a lot of similarities between R and Python, but working with this amount of tweets, it's pulling all public tweets like from a given time period. It's really easy to imagine how complicated that gets, especially when you're gonna doing text analysis. And then we're gonna compare at the end to American Customer Satisfaction Index to see if we're way off base or not. So here are the general steps. So we talked about getting, that's the first step. So you got to get the data in a form where you can put it into R, and then you have to clean it. So that's getting rid of the missing values. That's deciding how to deal with the things you want to filter out or exclude. It's getting it in a form where you can really easily kind of manipulate and analyze it. Second is the analysis and characterization. So a lot of data analysis problems are based on either classification or characterization. So you have all these data points and features that are describing a phenomena, and then you want to classify, you know, what that means on the highest level. So it's a lot of times pulling in different variables, different features, and then making kind of a decision about it. And then verification and visualization. So doing the sanity check, does this make sense? Do I have an error kind of in my analysis? And then visualizing it, whatever that could be. It could be a word cloud. It could be, you know, a report, a bar graph, you know, a time series. So for getting the data and cleaning it, the first thing when you use the Twitter API, so there's a package called TwitR that you can download that connects to the Twitter API. And basically, if you used APIs before, it's the same thing. So it's OAuth authentication. Just get this key and the secret, store them in variables, and it's pretty similar. You can Google that and figure that out in 10 minutes. And then you have a username, and the commands are so easy. So it's literally search Twitter, and then what you're searching for, and it will pull tweets. Twitter has it locked down to not pull historical tweets, so it will just capture tweets like at this moment. And you can go all the way up to the buffer. They've changed it, but I think it's like 2,500 tweets it'll pull for you. So what I did was search Twitter and then pulled kind of all the major airlines for @US Airways. So if you're upset with an airline, you're going to tweet at them, make sure they know, you know, how you feel about them, and then store them kind of in a data table each by airline. So when you pull the tweet from Twitter, it has more than just the text that you want. So this is the cleaning part, right? So I don't need, you know, his picture. I don't need his name. I don't even need his username. I don't need the time information. All of that is extraneous information for my problem set. And honestly, it will just get in the way. So I take all of this and put it into just a text string. It's much more manageable. And so you can see I'm using that lapply. That's that package that I kind of talked about whenever you're iterating over a data set. So I apply that to all the US Air tweets and use this function to just get the text out of it and then put it in usair.text. Pretty simple. So now comes the scoring. So if I have a string of text, this is a really actually complicated problem. How do I, decide if that's a good thing or a bad thing that's being said? How do I extract user sentiment? So there's tons of research on this, but the route that this guy went was to pull in a lexicon, an opinion lexicon of positive and negative words. So it's backed by research. It's like, they do extensive kind of sampling, and they decide that, free, timely, thanks, satisfied, those are all positive words, whereas wrong, upset, useless, idiot, those are all negative words. So that's kind of, we're essentially going to do a matching problem. You can probably, see that. So then I just wrote a script in R, which is essentially a scoring function that's going to loop over all of the tweets that we extracted. So basically, it's pretty rudimentary if you think about it. It's not as robust as we would like it to be, but just splitting up all the words, seeing if they match positive words or negative words, and then basically incrementing for each positive word, decrementing for each negative word. So then we can score for each tweet. So I think, forget which. We can score for each tweet and for each airline. And then let me just go back. So here, I'm guessing it was never and probably never. So both of those lit off a negative. So that's -2. So you can see, there's tons of ways to make this, more robust. So one challenge with text analysis is, the inversion. So I don't like something, it's going to fire off for like and fire off for don't. So there's ways to kind of get around that. There's also kind of stemming challenges, which is, adding ing or ed. So how does the algorithm kind of recognize those types of words? There's actually packages in R that do that for you. So they'll do stemming, and they'll also do kind of when words are up next to each other, how does it change the context? So you can make this much more complex, much more robust, but this is just kind of a first cut at the sentiment analysis. And then, we want to visualize it. So you're not just going to look through an entire table of tweets and look at their scores, right? So here's another good one. You can see delay, delayed, crazy, and annoyed. We're just doing a sanity check. That's a -4. So that's a negative tweet. And I kind of talked about another weak spot is sarcasm, as well as like pictures and links. It's definitely not going to kind of deal with that. So this is how we visualize. This is just the plot function in R. So you can see this is the scores and then the airlines. And you can see that a majority of the tweets are neutral. So that either means there's positive and negative and it's canceling out, or there's no hits for positive or negative. So for our purposes, we can't really, distinguish beneath that without writing another script or being more detailed. So Jerry, who wrote this, is cut that out and just kind of took the most positive, most negative tweets, and then this is the score he came up with. So the Twitter score, it seems like Delta, does the best, has a lot of positivity kind of on Twitter, whereas American and US Air, maybe not. So then you can even compare and pull in a different data set, which is the American Consumer Satisfaction Index. And it actually matches up kind of fairly well with that. So that's kind of an interesting takeaway. So that's kind of, does anyone have any questions about that example? Sound pretty cool, sound like interesting thing. Yeah.
And you got the library Twitter. What did you say about like the limited amount of tweets that you can get?
Yeah, so Twitter knows that their evaluation is based off of the amount of data that they have. They don't want to kind of give away the store for free, I guess. It's based off of, and there's ways to get around it, but by a username, I think they limit it in 2 ways. I think they limit it to like 2,500 tweets, like just the snapshot, like the pull in at one time, the command that says like get tweets. I think there's a limit on that. And then I think there's also a daily limit, how many times you can use that command. So I'm not like sure. I know they changed it. This example is from last summer. I know they've updated, every time they update their policy, they kind of change the settings of the API. So I'm not quite sure, but there is some sort of limit. And there's kind of ways to think about that. But any other questions? Has anyone done any kind of Twitter mining or social media mining? Not really. Yeah.
A few years ago, I was on a group called PSU Specials. What we did was we took the Twitter API and we searched for people who tweeted about bars in Penn State. And we went to the bars and we told them that if you had specials, get somebody to tweet from a specific handle, and then we'll pull your specials and put it up on the menu.
Mm-hmm.
So we had like 6 handles. Whenever they tweet specials, it would update on the website. And so it's called Blue had whatever, or the dead had something.
Yeah, that's cool. Yeah, another thing I did, just spinning off of this, there's a professor who was doing a lot of sentiment analysis on like the Penn State rallies. I'm sure you guys like heard of like Sandusky and stuff like that. So there's a really violent one in 2011 and a not so violent one in 2013, and they wanted to see kind of the impact of social media. I did the whole thing in R. I started doing it in Excel and it was just a mess. And then, I put it in R, and you kind of fumble your way around at first, but it becomes really intuitive to work in kind of the level of data frames and to understand kind of how you're looping through the information and how you're pulling different variables. So I definitely recommend it. Python is a great client as well, and that's being used more and more. But R has a lot of really powerful packages that make it really worthwhile. Are there any other questions? I mean, I didn't really have, the best, I guess, like approach or knowing kind of what you guys would want to learn or make the most of this time. So does anyone have any questions about R or data mining?
So if we want to learn how to work with R really quickly, just go through Swirl and.
Yeah, I really recommend it. I don't know if anyone started in here now, but it's great. Yeah.
I came a little late. Is there a way you can run back through how we access Swirl?
Yeah. So it's actually just, if you go to install.packages, so if you open R and if you open R, it's a package, so it'll download in R. So install.packages and
You go
Swirl.
to swirl.com and like just gives you everything about installing R, RStudio and stuff.
Yeah. Any other questions or any specific applications that you guys might be thinking about?
So there's this swirl stats.
All right, cool. All right, well, I'll hang around if you guys are working or if you want to run through R and have any questions, I'd be happy to help. I think it's an exciting field. I think there's a lot out there, and once you kind of get the swing of it, it is a steep learning curve, but it can be really powerful. So thanks, guys, for listening.
Yeah.